This is the Algebra 1 Summer School, Unit 3, Lesson 2, Function Notation, Part 2, Notes. All right, so yesterday we started looking at something called function notation. This notation is summarized below. So to review, function notation is spoken as, in this example, f of x. F means function of x. The number inside the parentheses is always an x value. It's an input, and what the whole function equals at the end is a y value. Let's review of how to use function notation with an equation, and then we'll move on to tables and graphs in this lesson. So we're going to start with the function g of x equals negative 4x plus 1. We're going to evaluate 3 different examples here. First, I'll start with g of 0. 0 is in the parentheses, so 0 is an x value. So what that means is I take that x value of 0 and put it into the function in place of x. When I put that 0 into the function, I put the 0 into the parentheses. Okay, negative 4 times 0 is 0 plus 1, which equals 1. All right, so when I put the input of x in, of 0, I get an output of 1. We often write our answer as an ordered pair, or you can leave your answer just as 1. In part B, we're trying to find g of negative 6. Well, negative 6 is an x value again, which means I'm going to put that x value of negative 6 in place of x in the function. So I have negative 4 times negative 6, which equals positive 24 plus 1, which gives me an answer of 25. If I were going to write this solution as an ordered pair, because the answer here is a y, I can write an ordered pair of negative 6, comma 25. That means that negative 6 is the x that matches the 25 for this function. All right, the last one here. I'm trying to find the x value. If we know that g of x equals 17, well, we talked about that if the function equals something, it equals a y value. So what I have here is that the function equals 17. So I take 17 equals negative 4x plus 1. All right, I'm going to draw my line down to keep organized. And to start here, I'm going to subtract 1 from both sides. 17 minus 1 is 16 equals negative 4x. And I'm going to divide by negative 4. 16 divided by negative 4 equals negative 4. That's the x value that I was looking for. So if I was going to write this as an ordered pair solution, I would have negative 4 as my x value and 17 as the y value that matches. All right, hopefully you're feeling more confident with function notation when we give you an equation. All right, today we will extend this idea of function notation to tables, graphs, and linear word problems. Okay, so in example 1, it says boiling water at 212 degrees Fahrenheit is left in the room at 65 degrees Fahrenheit, and it begins to cool. So we take a tub of boiling water, put it into a room that's room temperature. Temperature readings are taken each hour and given in the table below. In this scenario, the temperature T is a function of the number of hours that the water has been sitting in the room. So part A, it says evaluate T of 2. Well, 2 is the input here. But this time our input, it's not an x value. If I look carefully right here at this function notation T of h, it looks like h, or hours, is the input. So that 2 in the parentheses this time is an h value, or an hour. So what I'm going to do is I'm going to go to where h is 2 on the table and look at the output. Well, the output for hours of 2 is 104. So in context of the problem, this means that after 2 hours, the water is 104 degrees Fahrenheit. We're going to do the same thing here with T of 6. 6 is in the parentheses, which makes it in this example an input of h. H is hours. So I'm going to where h is 6 and I'm searching for the output. I get that T of 6, the temperature after 6 hours, equals 68. And that's the interpretation I'm going to write. After 6 hours, the temperature of the water is 68 degrees Fahrenheit. Now this time, let's read carefully here. For what value of H does T of H equal 76? Well, so I'm trying to find the hours this time, given that a temperature is 76. So when I look at my table, I find here the temperature is 76, and using that value, I can figure out that the hours, the H, equals 4. So again, what that means in context is that after 4 hours, the water is 76 degrees Fahrenheit. All right, last question for this problem. Since between what two consecutive hours will T of H equal 100? We have to know what the word consecutive means. The word consecutive means two things that come right after one another. So between what 2 hours next to each other will the temperature equal 100? Well, when I look at my table, it seems like 100 would squeeze in right here between 104 and 85. So it appears that between hours 2 and 3, our temperature will be 100 degrees. All right, so that's a little bit of how to do function notation from a table. Let's explore how to look at function notation given a graph. Okay. Here we have a function f of x. It's defined by the graph shown below. All right, this is called a piecewise linear function because it's made up of a bunch of different straight line segments. So we're going to answer each of the following. The first thing we have to do is look at the function notation. I'm given f of 1. Just as before, the 1 is in the parentheses, so it's an x value. Now that means in order to find the output, I'm going to go over to my graph. And I know that my x-axis is the horizontal axis, and the y is the axis that goes up and down. So I need to go to f of 1, x equals 1, which is right here, and I need to figure out the y value that goes with that point. Well, if I go up to the graph, it looks like that point right there has an x value of 1, but I need to find the y value. So I figure out how many do I count up to get to that point. Well, I counted up 1, 2, 3, 4. All right, so f of 1 equals 4, and I even wrote the ordered pair already for you on the graph. 1, 4. We'll do the same thing with f of 5. 5 is an x value. So what I do is I go to the graph at 5, and I find the point on the graph that has the x value of 5. I need to now find the y value that goes with that point. It looks like I counted down 2 to say that f of 5 equals negative 2, and the ordered pair representing that point is 5, negative 2. Now let's look at f of negative 3. So I go to negative 3, which is my x value, right here, and I go down to the graph at that point. I already know the x is negative 3, but I can count down 1, 2, 3, negative 4 in order to get the output value for that point. That tells me that negative 3, negative 4 is a point on this function. Negative 4 is the output that matches with the input of negative 3. Finally, f of 0. 0 is an x value here. So at 0, I go up to the graph and put my point. I know that the x value is 0, and it appears that I moved up 2 to get to that point. So the ordered pair for that point is 0, 2. Now let's think about things another way. Right? I'm going to erase this graph here so I can draw on it again. Now we're going to solve all the following for the values of x, which make them true. So notice here when I have f of x equals 0, that 0 is a y value. So I need to search for all the y values of 0. The way I like to do this, is to go to the graph where y equals 0. That's this portion right here. This whole line, we talked about graphing lines, is a line y equals 0. Now when I look at that line, it appears that my function crosses that line at 1, 2, 3 points. Now each of those points has an x value. This point right here is -1, 0. This next point is 4, 0. And the next point is 7, 0. When I look at that function, notice that all the y values of those points are 0, which is a good thing because that's what I wanted. And all the x values are different. The x values that gave me an output of y are -1, 4, and 7. If I wrote all of those ordered pairs out, I'll again be able to see how the y values are 0 and the x values are -1, 4, and 7. So when you're given a graph and asked to find x values that give you a certain output, when you look at the ordered pairs, that 0 should be the output for every point. Let's do the same thing for f of x equals 2. All right, so when I go to y equals 2 here, I'm going to draw a line here to keep things organized. It appears that my function only crosses that line at these 2 points. The ordered pair for the first point is 0, 2, and the ordered pair for the next point is 3, 2. Again, both of those points have a y value of 2, and the x values that match with that y value is 0 and 3. If I were to write the ordered pairs here, I would see I'd have the ordered pairs 0, 2, and 3, 2. Again, that shows me that the x value of 0 gave me the output of y, which I wanted, or output of 2, and so did the input of 3. Now the last question for this example says, what's the largest output achieved? So output are y's. What's the largest y value that this graph has? Well, most of the time when we're talking about largest values, that means a maximum. Right? So this point right here is the highest one. We call that the maximum, which we're going to explore more in the next lesson. That maximum, we want to know the x and the y value it occurs at. Well, that looks like it's the point 1, 4. That is the largest output, and the x value goes with on this graph. All right, one more problem here. Example 3. I have the function g of x shown below. We're going to do the same thing. We're going to evaluate points on this graph. G of -2. -2 is an x value. So just like the last example, I go to where x is -2, and I go down to the graph. It turns out that that point at x of -2 gives me an output of -3. Okay, so x is my -2, y was -3. At g of 0, I go to where x is 0, and again, I go down to the graph here until I find the point. That point has the x value of 0 like we wanted, excuse me, and the y value of -3. So again, the output here for 0 is -3. Now let's find g of 3. 3 is an x value, so I go to where x is 3 on the graph, and I trace up to the point. I know that 3 is the x, and I count it up 1, 2, 3, 4 to get the output. So g of 3 gives me an output, or a y value, of 4. Finally, g of 7. I go down to my graph here and get a point. Oh, I think I counted wrong. 1, 2, 3, 4, 5, 6. I did. G of 7. Well, looks like the graph actually crosses right there. I don't have to move up or down. So that x value is 7, and since I didn't move up or down, the output is 0. So I had an x of 7, a y of 0. All right, finally it says, what values of x solve the equation g of x equals 0? All right, the 0 here, again, is a y value. So I'm going to draw a line where y equals 0 and circle all the times that the graph crosses that function. Right? It appears to happen 4 different times. Well, this first x value happens at -3. So that's the first one. The next time I cross, looks like it's at the point 1, 0. 2, 3, 4, 5 is this next one. And then 7. Okay. Finally, very last problem. How many values of x solve the equation g of x equals 2? 2 is a y value. So I'm going to draw a line at y equals 2. Now the question here says how many values. So this time I just have to draw and count how many times that horizontal line I drew crosses the graph. It looks like there are 4 solutions to this problem. 4 times that line of y equals 2 crosses the graph of g of x. All right, that's the notes for lesson 2. I really encourage you to go ahead and try the practice for this lesson, as this is a little bit more complicated of a concept than we might have done in the past.